Good morning, sir. Myself Pallavi. I am from section A. My roll number is 244G5A0206. Subject name is analog circuit. Topic name is analog divider. Now coming to the topic, analog divider. So agenda, introduction to analog dividers, basic principles of analog divisions, type of analog dividers, design consideration for analog dividers, applications of analog dividers, performance matrices of analog dividers, and challenges and limitations. Now last one is conclusion and future tendency. Now coming to the introduction to analog. So analog divider. Now coming to the definition, analog divider process input signals to aid an output proportional to the ratio of two input voltages or circuits. This proportion is fundamental to various electronics applications, service as a critical component in signal manipulation and processing. Now coming to the process, the primary function of analog divider is to enable scaling and modulation of signals, which is crucial for accurate signals process in numerous applications from audio systems to precious measurements in instruments. Now coming to the applications, analog dividers are extensively utilized in signal processing, control system, instrumentation and other electronic fields where precise signals maintains required for effective operation and analysis. Now coming to the basic principles of analog division. So voltage division, they have the two divisions. First one is voltage division, current division and resistor division network. So voltage division means the voltage divider principles allows for the proportional distribution of input voltage across resistive component, facilitate the generation of low voltage for high input signals, which is crucial in many circuit designing. And current division means this principle describes how current flows through multiple pathways with the current being divided among branches inversely proportional to their resistance, enabling effective current management in complex circuits. Resistor network means serves as the backbone of implementing voltage and current division, where the arrangements and values of resistor dictate the output characteristics and behavior of the divider circuit. Now types of analog dividers. So we have the three types of analog dividers. What are they? Means positive dividers, active dividers, integrated circuits, means ICS. So passive divider means employing passive elements, components such as resistor. Positive dividers function without drawing power, relying slowly on the properties of the components involved in divided voltage or currents. And now coming to the active divider. Active divider means utilize amplifiers to achieve more precious and stable output, actively manipulating signals and able to provide power gains, making them suitable for more demanding applications. Now coming to the integrated circuits, IC based dividers represent a significant advancement in technology. Integrating multiple functions into a single chip allows for compact designing and enhanced functionality in modern electronic systems. Now design consideration for analog dividers. So design considering we have the two consideration. First one is impedance matching. Impedance matching means proper impedance matching ensures maximum power transfer and minimizing signals reflections and preserving the integrity of the signal within the divider's design, essential for high performance circuits. And second consideration means load effective. Load effective means the load connected to the output of an analog divider can significantly affect its performance, and consideration of load effect is critical in maintaining functionality and accuracy in signal processing. Now third consideration is temperature stability. So temperature stability means designing must account for temperature variation to ensure consistent performance and of analog dividers as temperature, impact resistance, and consequently the division accuracy. Now coming to the block diagram. Before going to the block diagram, what is the definition of analog divider? Means the analog divider is a circuit. The output is proportional to division of inputs. So V0 equals to V1 by V2 or V2 by V1. Now block diagram. In the block diagram, we have the two lag amplifiers will be used. So that is the lag amplifier 1 A1, A2, and the subtraction A3 and A4 will be anti-lag amplifier. The output equals to V0 equals to V1 by V2. So V1, V2 is the voltages and V01 is the output of the lag amplifier and V02 is the lag amplifier of the second amplifier, and that both outputs are given to the subtractant, that is the A3, and the output is given to the input of the anti-lag amplifier A4. The output will be used to the V0 equals to V1 by V2. Now coming to the circuit diagram, this is representation of the circuit diagram. So we already see the block diagram. So this is the log amplifier, subtractor, and this is the anti-lag amplifier. This is the circuit diagram of the anti-lag amplifier. Now coming to the applications of analog dividers. So we have the three applications. What are they? Means signal processing, measurement system, control system. So first one is signal processing. The analog dividers play an integral role in signal processing, enable the modulations and division of signals for clarity and effectiveness in transmission and repetition. And measurement system. In measurement system, analog dividers facilitates the accurate representation of measurements, ensuring precision in translating physical quantities to electronic signals. Now coming to the control systems applications. Used in control system to maintain desired operational level, allow for feedback and adjustment capabilities integrated to automatic processing. Now coming to the performance matrices of the analog dividers. So we have the three performance matrices. What are they? Means accuracy, linearity, and bandwidth. What is mean by accuracy? Means accuracy is a para amount in analog dividers, indicating how slowly the output matches the intended division, influenced by component tolerance and design choices. Now coming to the linearity. Linearity refers to the proportionality and relation between the input and output. High linearity ensuring consistent performance across operating ranges for favorable output behavior. Now coming to the bandwidth. Bandwidth means it indicates the frequency range over which the divider of the effectively. A wide bandwidth allows for higher frequency application, maintains performance integrity. Now coming to the challenges and limitations, we have the three challenges: noise sensitivity, component tolerance, power consumption. What is mean by noise sensitivity? Means analog divider of often susceptible to noise, which can disturb output and lead to inaccuracy, making effective design strategies essential to mitigate this impact. And the component tolerance means variations in component values, and power consumption is a critical corner, practically importable. Now coming to the conclusion and future things. So we have first one is key takeaways. The confluence of design principles, applications, and performance matrices illustrate the significance of analog dividers in electronic systems and highlighting their critical role in modern technology. And now coming to the emerging technology. So in emerging technology, advancement in semiconductors technology and materials science will continue to drive innovation in analog dividers, resulting in more compact, effective, and resultant designs. Future applications. Anticipated future applications for analog dividers span multiple sectors, including communication, consumers, electronics, and automation, reflection their fundamental roles in the emergency technology. This whole presentation is about the analog dividers. Thank you, sir.